Okay, I am going to share the screen. Can you all able to see the screen?
Yes, sir.
Is screen is
Yes, sir.
visible? Visible?
Yes, sir.
Okay, okay. Friends, I am going to present PPT. Okay. In last lecture, we see the differential mode of a operational amplifier, that is the qualitative explanation of the differential mode. And in this lecture, we are going to see the qualitative explanation of a common mode gain. Common mode gain. That is here the AC analysis of the common mode gain. We know that in differential amplifier, if we give input to the both the common inputs, that is the base of two transistor T1 and T2 or Q1 or Q2 with is supplied by the common gain or the common voltage, then any signal that drives both the input of the differential amplifier equally is called as a common mode signal. Interference, static and other kinds of the undesirable pick up the common mode signal, means that we know that the any wire, the basic function of the any wire acts as an antenna, and according to
Yes.
that the open wire of the base of the transistor, both the transistor Q1 and Q2, it will be acts as a antenna and it pick up the common signal. Means that in environment, in which environment the operational amplifier is to be working, in that environment the transistor, that is the base of both transistor, can pick up the some of the signal from that environment, and that signal will be known as a common signal. Any signal that drives the both the input differential amplifier equally, that will be known as a common mode signal. And the interferences means consider that this operational amplifier is operating nearer the highway, NH4 highway, then the interferences or the sound or the noise of that due to the transportation on the highway, it becomes the interferences, and due to that interferences the signals, the different signal are to be picked up by the basis of the transistor, both the transistor equally, and that will be known as an interference. Statics and other kind of undesirable pickups are known as a common mode signal. Consider that operational amplifier is to be working in the region or the in the atmosphere of the atmosphere of the MIDC. Then in that MIDC there are the different sounds, there are the different noise, and if both the transistor base of the transistor Q1 and Q2 can pick the interferences or the noises of the atmosphere, and due to picking up that noise and that signal that signal we see that what will be the idea behind that, that is that common signal, and that common signal will be picked up by base of transistor, and that will be known as a common mode gain. Figure shows the common mode. Next PPT will be shows the figure. The common mode signal, that is the V in common, which drives the both the input of the common mode signal, and the differential amplifier does not amplify the common mode signal. That is in transistor, as the transistor are the both the transistor are identical, equal emitter current will be obtained, and therefore it will be split into RE in next figure. And since the equal voltages VCM will drive both the inputs simultaneously, therefore it almost no current through the wire but emitters. See, between emitters. That is the figure C in next PPT. I will explain it in deep. That is shows the AC equivalent circuit, and when the common mode drives the differential amplifier large unbypassed emitter resistance. Large unbypassed emitter resistance appears appears in the AC equivalent circuit. A common mode signal in a common mode signal is the one that drives both the inputs in differential amplifier equally, and most interference, static and other kinds of undesirable pickup are common mode. And what happen is this, that is the connecting wire on the input base acts like two small antennas. See here, that is the any wire acts as an antenna, and due to that, in differential amplifier operating in an environment of the lot of the electromagnetic interferences or the noise interferences, it will be pick up the energy from that atmosphere, and each base pick up the unwanted interference voltage. The one reason one of the reason in the differential amplifier is so popular is because it discriminate against the common mode signal. In other words, the differential amplifier refuse to amplify the common mode signal, and because of this you don't get lot of unwanted interferences from that output. It means that is the basis of the both the transistors of the operational amplifier can pick up the same signal from that atmosphere where it is to be worked. And if that will be pick up the same signal, the same working of the both the identical transistor will be occur. We know that is the transistor, that is the base and emitter voltage is to be amplified at the collector. In case of transistor, what is the basic function of the transistor? That is, it will be amplify the signal which is to be connected in between the base and emitter. Okay, if the basis of the both the transistor will be absorbing the same signal, then what will be the effect? What will be the effect? That is the that is the working of the both the transistor will be equivalent, identical, and identical, that is the identical base voltage, identical currents are to be appeared in collector. Let us now find out why the differential amplifier does not amplify the common mode signal. And figure, that is figure 4.8, shows that the common mode signal driving the differential amplifier. As you can see, an equal voltage VCM drives the both the inputs simultaneously. Assuming that the transistor are identical, equal inputs be imply the equal emitter and equal input, equal emitter current, equal collector current the cell, and it will be balanced. We know that their magnitude will be the same, but the direction will be opposite. It will be appeared in operational amplifier or the differential amplifier, and it will be cancelled. It will be cancelled. That is the figure 4.8c shows and shows the AC equivalent circuit. Can you see that what this means? When common mode signal drives differential amplifier, large unbypassed emitter resistance will be appear. Consider this is the diagram. This is the diagram in which, consider I am taking the just laser point. This is the one of the transistor Q1 or T1. This is the another transistor T2, and the common voltages are to be applied at the base, where it will be applied at the base. This is the V in CM and this is V in CM. That is the common, both the common voltages are applied. This is the VCC and this is the VEE, and this is the V out. V out, that is the voltage is taken out here, that is the V out. This is the RC. RC is the collector current. We know that the collector current is to be used. This resistance will be used to balance the bridge, that is to balance the collector currents in both the in that is collector current, which is appeared between appeared in collectors of the both the transistor T1 and T2, and which is to be going to use for balancing the bridge. And for that proper balancing, for that proper balancing, RC here is to be used. Then here is the VCM in, and here VCM in is used. Then we know that, consider this is the VCC and this is the VE. Then the current will be flows in this direction and it will be passed through RE, and again the collector current will be flow in this direction and again passed through RE. That is, through RE the current, emitter current, will be passed for twice. And hence just to show the equivalent diagram, 2RE will be shown in emitter, 2RE will be shown in emitter, that is, this is 2RE, this is 2RE. Consider that just we are going to apply the AC analysis. We have to apply the AC analysis, and to apply the AC analysis we have to ground the all the biasing sources. See, VCC will be grounded, again VEE will be grounded. Then what about the AC equivalent circuit? We know that in AC equivalent circuit the collector current will be shown by the direction and the emitter current will be shown by the R dash E. See, this is the collector current will be shown by the RC, it will be the downward, then the VCM, then R dash E, and then 2RE, and again to the grounded. Here from in a right hand branch, just apply the DC equivalent circuit, sorry, AC equivalent circuit. This is the RC, this is the collector current, it will be shown by the arrow, it will be also shown downward direction. Then input to the base, that is the common input, it will be shown by the V in CM. Here notation CM is the common mode. We know that in last lecture we seen the differential mode, and again that current will be the present in emitter current is the R dash E, and at the end it will be goes to the 2RE, and hence it will be goes to 2RE. It means here the two biasing sources, here we see that there are the two biasing sources, means that here VCM will be shown, where VCM will be shown, R dash E, R dash E, that is the emitter current of the, sorry, emitter resistance of the both the transistor will be shown. Again 2RE is the high unbypassed resistance, that will be shown by the in operational amplifier, and this will be equivalent circuit. Again see that this is the collector current, this is the voltage, and if we apply the V is equal to IR, if we apply the V is equal to IR, see here, that is V out, that is V out. V out is equal to काय आहे झालं बघा, V out divided by, that is V is equal to IR, V is equal to IR apply करा, काय मिळतोय बघा, just apply V is equal to V is equal to IR, that is voltage VCM. I काय आहे, हा I आहे, that will be RC, आणि R काय आहे सांगा, R बरोबर काय येतोय आपल्याला इथं, that is R dash E plus 2RE, R dash E plus 2RE, आणि एवढ्यातच आपण अप्लाय करतोय किरचॉफ्स लॉ. त्यामुळे आपल्याला व्ही आउट इज इक्वल टू काय मिळेल सांगा, इथं आपल्याला VCM आउट, त्यामुळे आपल्याला रिलेशन मिळालं बघा, दिस रिलेशन मिळालं, V out divided by VCM is equal to minus RC divided by R dash plus 2RE. RE is very much greater, त्यामुळे फक्त हा काढून टाकला आपण, हा व्हेरी स्मॉल आहे, हा काढून टाकला, RC divided by RE मिळालं, आणि आपण यालाच पुढे म्हटलेलं आहे V out divided by कॉमन मोड सिग्नल जर असेल तर गेन ऑफ द कॉमन मोड आहे, आणि गेन ऑफ द कॉमन मोड मिळाली आपल्याला, काय मिळाली सांगा, दॅट इज RC divided by RE मिळाली. काय मिळाली बघा, दॅट इज द गेन विल बी, गेन काय मिळाली मित्रांनो बघा, गेन इज इक्वल टू मायनस आर सी मायनस का तर डाऊनवर्ड डायरेक्शन आहे, त्यामुळे मायनस आर सी आलं. इथं जो करंट आहे तो मायनस, म्हणजे करंट जो आहे तो डाऊनवर्ड डायरेक्शन मध्ये असल्यामुळे आपल्याला मायनस मिळालं. इथं मायनस आहे, तर मायनस आर ई मिळालं. त्यामुळे हे मायनस आर सी डिवायडेड बाय 2 आर ई मिळालं. आणि याला म्हणायचं कॉमन मोड गेन. याला काय म्हटलं मित्रांनो, कॉमन मोड गेन असं म्हटलं. आता कॉमन मोड गेन कशावर डिपेंडंट आहे बघा, आरसी आणि आरईच्या व्हॅल्यूवर डिपेंडंट आहे. इथं जर बघितलं तर आरसी आपण जर 10 किलो ओहम घेतला आणि आरसी आणि आरई जवळजवळ समान असतात असं म्हटलं, तर आपण आरसी ची व्हॅल्यू इथं 10 किलो ओहम घातलेली आहे बघा, 10 किलो ओहम, आणि 2 आर हे दोन्ही समान असल्यामुळं 20 आली. इथं मायनस काय आलं बघा, मायनस 0.5 आला. कॉमन मोड गेन मायनस 0.5 आला. म्हणजे कॉमन व्होल्टेजेस जर दिले बेसला तर ते काय होत नाहीत मित्रांनो, इट विल बी रिजेक्ट्स ॲट द आउटपुट. ॲट आउटपुट द कॉमन व्होल्टेजेस कॅनॉट बी एम्प्लिफाईड. ॲट आउटपुट common voltages does not amplified. In case of operational amplifier, common voltages are not amplified. Common voltages are does not amplified असं म्हटलं जातं. that is ACM. that is ACM is equal to काय आहे बघा, ACM is equal to minus 0.5 आहे. ACM is equal to minus 0.5. ACM is equal to minus RC divided by 2RE is equal to minus 0.5. अशा पद्धतीनं आपल्याला हे रिलेशन घेतलं जातं. आणि हे रिलेशन हे आपल्याला या एसी अनालिसिस मधून मिळतंय. म्हणजे यावरून आपल्याला असं लक्षात येईल की कॉमन व्होल्टेजेस हे ऑपरेशनल एम्प्लिफायर मध्ये काय केले जात नाहीयेत, काय केले जात नाही, एम्प्लिफाय केले जात नाहीयेत. आणि यावरून कॉमन व्होल्टेजेस हे रिजेक्ट केले जातात. इथं बघा नेक्स्ट पॉइंट आहे कॉमन मोड रिजेक्शन रेशो. कॉमन मोड रिजेक्शन रेशो. सोपान, हे सोपान, हे सोपान, जरा पाणी आण रे. Common mode rejection ratio, that is the data sheet of the common mode rejection ratio, that is CMMR, is defined as ratio of differential voltage gain to the common mode voltage gain. तो रेशो आहे, कशाचा रेशो आहे बघा, डिफरन्शियल मोड गेन टू कॉमन मोड गेनचा रेशो आहे. आणि हा रेशो म्हणजे आपल्याला CMRR आहे. इथं ही ए गेन म्हणजे काय आहे मित्रांनो, गेन ए म्हणजे काय आहे, डिफरन्शियल गेन आहे. दिस इज द डिफरन्शियल गेन. हे काय आहे बघा, कॉमन मोड गेन आहे. दॅट इज डिफरन्शियल गेन डिवायडेड बाय मायनस द कॉमन मोड गेन. हे जर बघितलं आपण, ए जवळजवळ किती आहे बघा, इथं 200 आहे, 200. दॅट इज द डिफरन्शियल गेन विल बी व्हेरी व्हेरी हाय. means that is the voltage gain in the differential mode, that is the very high in case of operational amplifier. In operational amplifier voltage gain is very high. Okay, then consider A is 200, then minus ACM is equal to minus 0.5. Then common mode rejection ratio, common mode rejection ratio, that is the ratio of the differential gain to the ratio of the common mode gain, that is known as an common mode rejection ratio, and it will becomes to the 400. Means the common mode rejection ratio is very very high in case of operational amplifier than that of the differential amplifier. And CMMR is equal to 20 log of CMMR. आणि इथं जर CMMR हा 400 जर घेतला मित्रांनो, तर log is equal to 20 log of 400 is equal to 52 dB. That is the decibel. That is the dB is the unit to calculate the CMRR. Okay. Here next point 4.5 shows the operational amplifier symbol. आणि सिम्बॉल मध्ये काय आहे बघा, दॅट इज इंट्रोडक्शन. इंट्रोडक्शन मध्ये काय आहे बघा, एन ऑपरेशनल एम्प्लिफायर इज बेसिकली अ हाय गेन डायरेक्ट कपल्ड एम्प्लिफायर. हाय गेन डायरेक्ट कपल्ड एम्प्लिफायर आपल्याला माहिती आहे डायरेक्ट कपल्ड आहे. इथं डिफरन्शियल एम्प्लिफायर असतो आणि डिफरेन्शियल एम्प्लिफायर कपलिंग करतो. दॅट इज हाय गेन डायरेक्ट कपल्ड एम्प्लिफायर. इट हॅज टू इनपुट अँड वन आउटपुट. टू इनपुट असतात आणि वन आउटपुट असतो. But generally it is operated in single ended input, single-ended input, single-ended output mode, and the differential mode forms the first stage of the operational amplifier. Inverting input, non-inverting input असं म्हटलं जातं मित्रांनो. इथं इन्व्हर्टिंग इनपुट आहे, हा दाखवलेला आहे. इन्व्हर्टिंग इनपुट हा नेगेटिव्ह साईन दाखवलेला आहे, कारण या दोघांच्या मध्ये फेज रिव्हर्सल असतं. दॅट इज द phase relation between the inverting input and output is 180 out of phase. That is the phase relationship आहे. इथं इन्व्हर्टिंग दाखवलं जातं. इन्व्हर्टिंग दाखवताना इथं निगेटिव्ह आहे. नॉन इन्व्हर्टिंग आहे मित्रांनो. नॉन इन्व्हर्टिंग दाखवताना इथं पॉझिटिव्ह आहे. पॉझिटिव्ह नॉन इन्व्हर्टिंग का, तर इनपुट आणि आउटपुट मधला जो फेज रिलेशन आहे इथं तो 180 आउट ऑफ फेज असतो. 180 आउट ऑफ फेज आहे. It has two inputs, one output, but generally it is operated in a single-ended input, single-ended output, and the differential output. That is the first stage. आणि पुढे जाऊन बघितलं आपण, that is the IC चं आपल्याला इथे एक चित्र दाखवलेलं आहे, पिन कनेक्शन दाखवलेलं आहे. That is the input and output voltages with respect to ground measure केलेले असतात. The inverting input has a minus sign because it indicates 180 out of phase shift between input and output signal, and non-inverting input phase is shown by the plus sign, and which indicates no phase inversion between input and output signal. That is the pin connection. Here we see the pin connection. The IC number is equal to 741 IC. It is the operational amplifier, and in IC the total built up is the total all the block diagram. All the block are to be built inside the IC. IC 741 is widely used for the operational amplifier application, and in this IC, that is when input is 0, output can be adjusted by the zero adjuster. That is, zero adjuster is the offset null terminal. Consider this is the NC, no connection is here. 8 terminals is there is the notch is nearer to 1, and it will be the clockwise 1 2 3 4 5 6 7 8 clockwise जायचं मित्रांनो. क्लॉकवाईज जायचं, क्लॉकवाईज. नॉचच्या जवळ एक असतं, एक, पुन्हा 2, पुन्हा 3, पुन्हा 4, 5 6 7 8. क्लॉक कसं फिरतं, क्लॉक कसं फिरतं बघा. हे क्लॉकवाईज आहे का अँटी क्लॉकवाईज आहे, जरा सांगा मित्रांनो. मी जे दाखवलं ते क्लॉकवाईज आहे का अँटी क्लॉकवाईज आहे मित्रांनो. अँटी
अँटी क्लॉकवाईज.
क्लॉकवाईज. यस, अँटी क्लॉकवाईज आहे, नॉट क्लॉकवाईज. सगळे जागे आहात. या नॉचच्या जवळ एक लिहायचं खालून, 1 2 3 4 5 6 7 8 असे नंबर आहेत हे पिनचे. एक नंबर ऑफसेट नल आहे. ऑफसेट नल म्हणजे आपल्याला माहित आहे, म्हणजे ज्या वेळेला कॉमन व्होल्टेज दिलं जातं ते कॉमन व्होल्टेज हे आपल्याला कलेक्टर्स मध्ये काय मिळालं पाहिजे, 0 मिळालं पाहिजे, नल मिळालं पाहिजे. हे नल जोडायचं. इन्व्हर्टिंग इनपुट आहे 2 नंबर, 3 नंबरला नॉन इन्व्हर्टिंग इनपुट आहे, 4 नंबरला निगेटिव्ह व्हीसीसी आहे, 5 नंबरला ऑफसेट नल आहे. ऑफसेट नल दोघं एकमेकाच्या समोर आहेत बघा. ऑफसेट नल दोघं एकमेकाच्या समोर आहेत. 6 नंबरला प्लस व्हीसीसी आहे, 7 नंबरला ट्रिगर व्होल्टेज आहे, 8 नंबरला नो कनेक्शन. 8 नंबरला कसल्याही प्रकारचं कनेक्शन नाही. अशा प्रकारचं इथपर्यंत आपण बघितलं ब्लॉक डायग्राम. आपण नेक्स्ट लेक्चरला बघूया ब्लॉक डायग्राम. ब्लॉक डायग्राम आणि बाकीच्या गोष्टी ज्या कॅरेक्टरिस्टिक आहेत त्या आपण नेक्स्ट लेक्चरला बघूया. काय जाऊ एकदम झालं, एक मिनिट. काही प्रश्न असतील तर विचारा.